Welcome back to UAP Rant. This is episode 18 in the podcast series so far. A series of 5 minutes podcasts on UAP and UFOs, and what we think is a key link to Maxwell's original quaternion notation, which included a term for four-dimensional scalar space, and that is a precursor to Einstein's special theory of relativity and heavy-size modification of the quaternion to a three-space vector field and the equations we have today for electricity and magnetism. So just to quickly recap from previously, in terms of quaternions, they offered a four-dimensional framework combining space, which is three-dimensional, and time, which prefigured Einstein's space-time. Then we had heavy-side simplifications, which made Maxwell's equations easier to connect with relativity and the concept of space-time. And we had Einstein's relativity itself built on the mathematical groundwork of Maxwell and Heaviside, explicitly trying to tying time or linking time to the three spatial dimensions to form the fourth dimension. So through the quaternion notation and Heaviside's vector formalization, Maxwell and Einstein's ideas converge to reveal the fourth dimension as a dynamic interplay of time with the spatial dimensions governed by the laws of electromagnetism and relativity. So I wanted to pick up some more notes here, pick up more on that today, and follow it up, and circling back to UFOs and UAPs and how they work, and why we are confused by the five observables, including instantaneous acceleration. Now, to connect the concepts of the fourth dimension as a scalar quantity, hyperspace, and the idea of jumping between two relative coordinates in space and time, we can explore the physics and hypotheses behind interdimensional travel and unidentified aerial phenomena, or UAPs. And we can also link that back to the observations and papers we've written on orbs and rods for our research in the field, and how craft and those objects appear to defy our temporal understanding of time and space. And to do that, I think we have to go back to that quantity in Maxwell's quaternion notation, which determined time as scalar and four-dimensional, and how it's connected to the other three space quantities in a vector field. So the fourth dimension in space-time as a scalar quantity is typically treated as a coordinate that interacts with space. But if you consider it as scalar rather than a vector in the context of interdimensional travel, then we can shift focus to time as an independent measure of change or state. And what I was alluding to before is then we have length contraction and time dilation can become measurable. It's like thinking of the past, present, and future all coexisting at the same moment forever, rather than time having a direction or being a vector. So it's scalar. So all past, present, and future exist simultaneously. So if time is a scalar field, then instead of a strict axis of time, which we've become used to, time can be seen as a scalar field that permeates all points in space simultaneously. So objects moving through that four-dimensional scalar space, which we'll call hyperspace or higher dimensional realms, might manipulate the scalar field to alter their temporal or spatial position. So in other words, it becomes navigable, because it's no longer a vector. It doesn't have a direction. Okay, everything exists at once. An example would be if time can be compressed or stretched in specific regions like near black holes, then manipulation could explain the ability to jump across vast distances or times relatively instantaneously or quickly through length contraction and time dilation. Now that perspective aligns with the hypothesis where advanced civilization used localized distortions in space-time to traverse enormous distances or even move between temporal points like the past and the future. Because in scalar time, all the past, present, and future exist simultaneously. So it's like going from a planet on one part of the galaxy to a planet on another part of the galaxy almost instantaneously. So no time has passed because there's no direction. So instead of any sort of age difference traveling at the speed of light through physical space, like Einstein was saying, you come back and time's moved on and you haven't, we've got a temporal and spatial distortion where you're almost instantaneously moving between two coordinates, say in a matter of hours or days at the most, across or between solar systems in the galaxy. So we eliminate time as a vector. So that leads us to understanding more about hyperdimensional travel when we consider the scalar, the time term in the quaternion notation as scalar rather than being a differential of calculus and converted into three space vector fields, which led to linking the Lorentz equations to space-time through Einstein's special relativity, but time was still considered to have a direction within that vector field. So I think we need to go back to the quaternion notation and the idea that time is actually scalar, because that still holds special relativity still holds true, and I think within that mass that you say a craft that you're in, you overcome inertia if the technology that is applied to travel through hyperspace negates the mass. Then you can also inside that craft maintain Newton's laws as well, because you've negated mass in a scalar field, so you can jump anywhere, harnessing available energy, and we talked about electric space in the fourth dimension, and you're also overcoming inertia because you've negated mass, and therefore Newton's laws can still apply to a person or biologics or objects within that mass contained within that field. I'll leave it at that now. We'll talk more about orbs, rods and craft and scalar time in the next episode.